Electric vehicles and smart homes are really topical right now. In this video, we are going to talk about home microgrids and smart charging. First, let's set up the baseline in the software, a medium residential load with an EV and a flat retail tariff. The EV charges based on a schedule which we configured to be from 4 to 9 p.m. during working days and from 1 to 8 p.m. on the weekend, a typical charging pattern of an employee who charges their car at home. The homeowner pays 31 cents per kilowatt hour for all consumed electricity. In the participants and value flows part of the software, we can assign these items to participants. Let's say the homeowner pays for the bundled retail tariff. The supplier gets that tariff and pays for the network charges separately, which make up the revenue of the network operator. In our second scenario, let's assume we invest in 20 kilowatt solar PV on our house. As we are based in the Netherlands, we are benefiting from the net metering scheme that lets us deduct all exported electricity from our total imported electricity, and we only have to pay the difference. We configured that via an export tariff item at the same rate of the retail tariff that we allocate as a revenue to the homeowner. This scheme is very lucrative, especially when electricity prices are high, but while its phase out has been announced and delayed multiple times, currently it is expected to start from 2027. So, in the next scenarios, let's have a look at a smart home independent of net metering. In the third scenario, let's delete the net metering tariff, replace the flat retail tariff with a dynamic time of use one, and add a small 10 kilowatt hour or 5 kilowatt residential battery. In this scenario, the homeowner only makes use of the distributed energy resources themselves, rather than selling anything to the grid. Let's also change the charging schedule to a smart one. The charger knows that the EV is plugged in every day between around 5 p.m. to 7 a.m. and will choose the cheaper times to charge the vehicle. In the fourth scenario, let's say we can increase our revenue stack by exporting into the wholesale market whenever lucrative. For that, we will add the Netherlands wholesale market from the last 12 months to our site meter. Let us quickly have a look at the asset optimization part of our software. We have defined 3 participants: the supplier, the network, and the customer. Since we are interested in optimizing the project for the customer, we click Participant Level and select Customer in our window. Now, let's click Run Simulation. When the simulation is finished running, we can jump directly into the Relative Cash Flows tab. We see that the net metering supported PV system is the most lucrative for the customer. Scrolling down, we can see that with our inputs, this results in a payback period of 3 years. However, the other scenarios also save the customer money in comparison to the baseline. Unsurprisingly, the fourth scenario with the dynamic tariff, solar and BESS, and smart charging schedule, as well as the ability to export electricity into the wholesale market, is the second most attractive one, after the pure solar net metering scenario. Comparing the dumb EV charging pattern of the baseline to the smart charging in the fourth scenario, we can see that the car is now charged during different times. This saves the car owner money and reduces strain on the grid. Gridcog demonstrates the value of smart homes through its capability of modeling dynamic charging and flexibility.